mechanical linkage of a robot. It is a mechanical linkage of the robot. Okay, and now I wanted to explain you what are the basic important components of the robot. Important components of the robots you can see here. Just I will be writing one small figure to show you a simple the components of the robot. You need not to write it, just I wanted you to understand how to write them up. Suppose you say it is a robot, and this particular robot will be having, these are called end effectors. End effectors are the fingers or the grippers. Okay, and this particular thing is called wrist of the robot. Wrist of the robot. And this whole thing, it is a mechanical linkage of the robot. This will be called as the manipulator of the robot. Manipulator of the robot. So already I told you what is manipulator. Manipulator is the mechanical linkage of the robot. Then which will be having a controller. Controller is one which will be governing whole robot activities, which will be governing whole activities of the robot. And another one which will be having the sensors. Sensors are those, these are interfacing between the robot and the outside world, so that the robot can able to flexibly interact with the external world in a very flexible manner. Okay, so basically, as I told you, the basic parts of the robot are, please try to remember or understand, the manipulator, sensor, and controller, then end effector, and the important thing is power drives. The power drives are basically three types of power drives we have: hydraulic power drive, pneumatic power drive, and electric power drive. These are the important components of the robots. So without these, no robots will be existing. These are the important components. Now next, the robot may be engaged in welding operation, it may be engaged in the painting operation, it may be engaged in pick and place or assembly operation or welding operation, whatever the operation it may have. The physical structure, the physical appearance, the physical structure of the robot or configuration of the robot. The configuration of the robot we have to think about. There are basically four configurations of the robot. There are basically four important configurations of the robot. Under them, all these will be falling. One is Cartesian, and the second one is cylindrical, and the third one is the spherical, or also it is called as polar, and the last one is the SCARA: selective, compliance, assembly, robotic arm. Simply you can say articulated robot arm. Robot arm. All these I have written in this systematic way because I wanted to talk about, or I wanted to make them in what way they are different. I wanted to talk about this, so that I have taken in this similar way. And please look into the first one, Cartesian coordinate robot. The Cartesian coordinate robot will be in this form. Please try to remember how to write them up. or a simple figure I'll be giving you. Try to remember that figure, or even you can write the figure. Okay, you can write the figure of the similar kind. And you can see here, simple linkage you write. You need not to write a 3D figure. It is a vertical column, and this is a base, and this will be called as end effector. Please write this much. It is enough. So this is a z direction movement. Okay, this is a z direction movement. It can move along the z direction, and it can move along the y direction, and it can move along the x direction. So here the important configuration of the robot, the physical structure, how it makes the work envelope. The understanding of the envelope I told you. Suppose you say a person is standing here, and he has been taken one thread, and there is a stone at the other end. He is trying to rotate around him an imaginary cover or imaginary envelope which is generated around his body is called as work volume of the robot. Please understand, the work volume of the robot is, the end effector is flexibly moved around its manipulator. An imaginary cover or envelope which is generated around the robot is called the work volume of the robot. Work volume or work envelope of the robot. Now, work envelope of the robot will be in the form of a rectangle in this case. It will be in the form of a rectangle, so that it is called as Cartesian coordinate robot. It is called as Cartesian coordinate robot. And you can see here the first very important points I'll be writing at the same time. You can look into this. The first important point is that it is having the coordinates as x, y, z. It is having the work volume in the rectangular form. It is having work volume in the rectangular form. And the third one, it is having the x, y, z movements will be linear. It is also called as LLL robot, or simply you can say it is 3L robot. And since it needs to move in a linear way, please look here. If I have to define a line, the 2 points are enough. If I have to define a spine, I need to have many closely spaced points. Please remember, the coordinates required for this plane will be more than a straight line. That means so many points it has to remember in the 3D world. So in a very linear way, you can see that only the 2 points are enough. So definitely the robot controller which is required will be very simple one. A simple robot controller is required. Okay, and the repeatability and accuracy will be uniform throughout the work volume. Repeatability and accuracy is uniform throughout this one. And to explain or to discuss about this, the repeatability and accuracy, mostly it may not be required to you, but even though just I wanted to discuss about this. You can see here, repeatability and accuracy will be uniform throughout the work volume. I say, please look here. I have been given this particular rectangular shaped work volume of the robot. It is out of our scope. Just I am going to discuss some of the things in this. It is the rectangular form, and I have been given. Please understand, I have been given you a cake. I wanted 8 of our friends to, or 10 of our friends to equally divide this and give, or equally divide this and eat, but it should be in the similar shape. Equal quantity. You can see that I can divide this into so many parts. For example, I can divide this into 9 parts. For example, I am going to divide this into 9 parts. You can see any one segment you take 1, 2, 3, 4, 5, 6, 7, 8, 9. Any segment you take, that segment will be having a similar shape and similar size. You can see here. Any segment you take, that will be having similar shape and the similar size. That means to say the spartally resoluted work volume of the robot will be uniform throughout this work volume. The spartally resoluted work volume in the sense a segment of any work volume will be similar throughout the work volume. That means to say the repeatability and accuracy will be uniform throughout the work volume of the robot. You can see that whatever they want, you can divide them. It will be having a similar shape, equal size. That means the robot end effector can able to flexibly locate its end effector at the similar point repeatedly. That means to say the repeatability and accuracy of the work volume will be very good in case of the rectangular coordinate robot, that is a Cartesian coordinate robot. Now this is another point. And the next important point is the application point of view. This robot can able to do pick and place. It can able to do pick and place, and it can be used for machine loading and unloading. It can be used for machine loading and unloading. And one can think that machine loading and unloading, what difficult it is. It is a very, very important thing. Already you know that in CNC machines, loading the part is very, very important, because it has to start with a particular coordinate position. So the positioning with what accuracy you are going to place this workpiece on the table of the machine is very, very important. That can be done by using these robots. So this is about the application. And please try to remember once again, I'll be explaining the coordinates of these robots is X, Y, Z. The work volume generated by these robots will be in the form of a rectangular shape, hence they are called Cartesian coordinate robots. These robots are having linear movement along the X, Y and Z directions. That means linear along the X direction, linear along the Y direction and linear along the Z direction. It is also called as 3L robot or LLL robot. Since the spartally resoluted work volume of the robot is uniformly distributed throughout the work volume, that means to say one piece if you have taken, it will be representative of whole segments within the work volume. That means to say the repeatability and the accuracy of the robot will be very good throughout the work volume. Okay, work volume. And what about the application point of view? Application, it can be used for the pick and place. As I told you already in the previous class, any robot which cannot do any pick and place, it is called as not called as a robot. Robot minimum has to do a pick and place. Okay, and another one important thing is that it can be used for the machine loading and unloading operations. And these robots are not used for the machine assembly and complex operations like welding and some other painting operations. It is not possible because all are prismatic joints. Linear joints are prismatic joint. Linear or prismatic. The linear or prismatic means what? The linear or prismatic in the sense, it will be like this, you can see here. Just I will be showing you. You can see here, this block can move, but it cannot rotate. It is called linear or prismatic joint. This joint is called as linear or prismatic joint. Now, let me come to the other one. The second one is cylindrical coordinate robot. Cylindrical coordinate robot. So please try to remember how to write the figure. I am giving you very simple way of writing the figure. Very simple way of writing the figure I am giving you. Look here, this robot can be written like this. Very simple sketch I will be writing. You need not to follow the book sketch. It is not required to follow it. That's all. You can write this much. So this can move along this z direction, and it can rotate along this, and it can move along this. So it forms a cylindrical shape of the work volume. You can see it can be a cylindrical shape work volume. The work volume of the robot will be in the cylindrical form, so that this is called cylindrical coordinate robot. Okay, and first point, it have the axis, r theta z. I say it is r, okay, radius, and this will be a theta, and this will be z. R theta is the coordinate, and these robots are also called as LRL robots, or simply we can say 2L and 1R robot. Rotational, revolute, linear, rotational, linear. Linear, rotational, linear. And since the work volume generated by these robots will be in the form of cylindrical, so that they are called cylindrical coordinate robots. They are called cylindrical coordinate robot. And another one, what about the accuracy and repeatability? Please look here. Again, I will be justifying the repeatability and accuracy will not be informed throughout the work volume of the robot. I wanted to justify it here. It is not required, you have to write. It is not required, just I will be writing it. You say, I have given you a cape of this shape, cylindrical shape. I wanted you to equally divide this and give it. What you do is, please look here. I am going to divide this. I am going to divide this. Please look here. I am going to divide this into number of parts. I am dividing it into number of parts. So look here. So many parts.
Excuse me, sir.
Yeah.
Well, there are so many people who are waiting to join the class. Can you please let them in?
See, I'm making record. Please don't talk in between.
Sir, but they're gonna miss the class.
So what I have to do? Throughout the class, I have to allow them. See, look here. I am going to take this. The shape of this work volume will be like this. If I have taken this, the shape of the work volume will be like this. You can see here the shapes will be different. For the similar given segment, the shape of these will be similar, and outside the spartally regenerated work volume will be bigger size, and inside it will be smaller size. That means the accuracy and repeatability will be very good in the inside the cylinder, and how you are going outside, the repeatability and accuracy will become poor.